Okay, hello everyone. I welcomes to all in another new class belongs to electricity and magnetism, and in this class we are going to discuss about electric field intensity due to an electric dipole at any point P. So this is the electric dipole, that means two opposite charges separated by a distance 2a and a arbitrary point we have been considered P, which is distance r from the center of the electric dipole, and what will be the electric field intensity at this point, that we are going to calculate. Okay. So here you can see this is the positive charge and electric dipole moment, that is your P vector along positive x-axis direction, that we know. So here you can see the line joining from the center of the electric dipole, this one O, to P makes an angle theta with this x-axis or with P vector. So hence P has two components, one will be cos theta and another will be the sin theta. Cos theta component will be this one, P cos theta, and P sin theta component is this one. So this vector P cos theta vector along this way, line joining from O to P, and another P sin theta which is perpendicular to this line OP. We can say that the P point is an axial point for this dipole moment. P cos theta is the magnitude, and this P point is the equatorial point, or situated on the equatorial line of the electric dipole moment having the magnitude P sin theta. Now, what will the value of electric field intensity at point P due to P cos theta and P sin theta? So here you can see, as this point P is on the axial point, or if as this point P is called as so-called axial point for this P cos theta, so due to P cos theta, the electric field intensity will be along PQ, suppose E1, and due to this P sin theta, as P sin theta, if we are going to consider P sin theta dipole moment and this point P, then P point is nothing but your situated on the equatorial line of this P sin theta. So hence for the P sin theta, electric field intensity at point P will be along this direction, along PS direction. Let this is your E2. Now what will the magnitude of E1 and E2? Here I have been written E1 value is your 1 by 4 pi epsilon 0 2p cos theta by RQ along PQ direction, and E2 will be 1 by 4 pi epsilon 0 p sin theta by RQ along PS direction. Why this is, how this value will be? Here you can see, I am going to show you. If we are going to consider the point situated on the axial, then what is the magnitude we found? We found 2p by RQ, and here the dipole moment is P vector and the magnitude is your P. Okay, so if I am going to compare this situation, then here the magnitude is your P cos theta. So instead of P we have to write P cos theta, so 2p cos theta by RQ. Here you can see this is 2p by RQ, but here in this situation this is P cos theta, so obviously it will be 2p cos theta by RQ. Likewise, when we have been discussed about equatorial case, for the equatorial case we found at point P, which is the equatorial point of this dipole. For this case we found the electric field intensity at point P is your P magnitude by RQ, only P magnitude. You just forget the minus sign is giving the direction. So here P magnitude by RQ. Okay, and here is the dipole moment was the P vector, and so here it will be P magnitude by RQ. If we are going to consider this situation, here instead of P, P sin theta is there, so E2 will be, that means at point P, due to P sin theta component, the electric field intensity E2 will be 1 by 4 pi epsilon 0 P sin theta by RQ. And here you can see, whenever we discussed about equatorial case, this is the dipole moment, this is the dipole moment, and electric field intensity was along this direction, that means opposite to the dipole moment. If the dipole moment along this direction, the resultant electric field intensity along this direction we found. Likewise, if we are going to consider this dipole moment, that is your p sin theta, for this case p sin theta is along this direction and corresponding uh, electric field intensity at point P will be just opposite, that means along PS direction. So along this direction is your P sin theta and this direction is your electric field intensity at point P. Okay, and here the value of E2 will be P sin theta by RQ along PS direction, PQ direction. E1 is a P uh, along PQ direction. Now the resultant magnitude will be obviously E1 square plus E2 square root over, that means along the diagonal of this rectangle if we are going to consider. So this PR will be the resultant or net electric field intensity at point P due to this dipole moment and this dipole moment. Okay, now we are going to substitute the values. So here we found E1 value, here we just substituted over here and here 1 by 4 pi epsilon 0 taken outside, it is the common factor, and 2p cos theta by rq, here 2p cos theta by rq square is there, square 2p sin theta by rq square, right? Okay. Now we are going to go for the further calculation. Here you can see 2p cos theta by rq whole square, p sin theta by rq whole square. So it will be 4p square cos square theta by r to the power 6, and this will be p square sin square theta by r to the power 6, whatever written over here. Okay. Now here p square r to the power 6, if we are going to take outside of this root over, then it will be p by rq, remaining will be 4 cos square theta plus sin square theta, and this 4 cos square theta will be written as 3 cos square theta plus cos square theta, and here this is the sin square theta here written as such. So cos square theta plus sin square theta will be 1 and this will be 3 cos square theta. Finally, we found the magnitude of electric field intensity at point P will be equal to this much. But its direction, if we are going to consider, the direction will be along PR, this one, along PR direction. Okay, or the diagonal of this, along the diagonal of this rectangle, of the PSRQ rectangle. Okay, so here along PR direction. Okay, along PR direction means what? Along PR direction means angle between P vector. P vector means P vector is along positive x-axis direction, and E vector means along PR direction. What will the angle? So the net angle will be how much? Theta then beta. So here PR direction means angle between P and E, that is theta plus beta, right? Now we are going to calculate the value of beta in term of theta from the triangle. If we are going to consider triangle, or you can see from the figure, this triangle you consider PRQ triangle, tan beta will be equal to how much? This, if this is beta and this is your perpendicular and this is the 90 degree, so this will be RQ by base is your PQ, same thing it has been written RQ by PQ. Okay, and RQ is nothing but RQ, here RQ is nothing but magnitude of E2 vector, and PQ is nothing but magnitude of E1 vector. Okay, now we are going to substitute those values already we have been found. Here you can see already we found these values. I'm going to show you here these values. E1 we found 1 by 4 pi epsilon 0 2p cos theta by rq. E2 magnitude is your 1 by 4 pi epsilon 0 p sin theta by rq, that we are going to substitute over there. Okay, here we are going to substitute E2 value is your 1 by 4 pi epsilon 0 p sin theta by rq, and E2 value or magnitude 1 by 4 pi epsilon 0 2p cos theta by rq. So here after calculation we can found that here you can see that 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 got cancelled, and RQ got cancelled, P got cancelled. This will be 1 by 2 sin theta by cos theta tan theta. Here we found tan beta will be equal to 1 by 2 of sin theta, right? From this expression, tan beta equal to half tan theta, we can found that if theta will be 0, beta also 0 degree. If theta will be 90 degree, beta also will be 90 degree. How it is? Suppose we are going to consider theta will be 0 degree. That means tan beta will be how much? 0. That implies beta has to be 0 degree. Okay. Likewise, if theta will be 90 degree, here this side tan 90 degree is your infinite. So tan beta will be infinite, hence beta will be 90 degree or pi by 2. Beta should be pi by 2 or 90 degree. Okay. So here if theta will be 90 degree, beta will be 90 degree. If theta will be 0 degree, beta also will be 0 degree, right? Now we are going to consider two cases. For theta will be 0 degree, that means if the point P will be situated on the axial, on the axis, or on the along the axis of the uh, uh, dipole moment. So dipole moment is placed along the x-axis. So axial line means along x-axis. So if we are going to consider any arbitrary point P over here, then what will be the electric field intensity at this point? That means any point on axial line. So if this situation is going to rotate like this, as we saw that when theta will be 0, that means here theta will be 0 degree. Theta rotated to 0 degree, beta has to be also 0 degree. So this beta, that means the resultant vector direction with respect to E1 is your beta, no? So this beta will be 0. That means resultant electric field intensity, this electric field intensity will be along this direction, along axial line, what we already found earlier. Okay, and the value will be how much? 1 by 4 pi epsilon 0 2 p vector by r cube, and along OA direction, along OA direction. Okay, these things already we have been found whenever we have been discussed separately. And how we got this value? Here theta we can put here 0. If I am going to put theta will be 0, this value will be 3. 3 plus 1 4, root over of 4 will be 2. So we found 2p r cube. Vectorially if we are going to represent, then it will be 2p 2p by r cube. Okay. Now we are going to consider another case, that is your theta will be 90 degree. Theta will be 90 degree means like this. That means we are considering the point will be on equatorial line. If it is so, what we found here, if theta will be 90 degree, beta also will be 90 degree. That means this beta will be 90 degree. 90 degree means like this, 90 degree. That means E, the resultant vector, will be along this direction, right? Now if I am going to put the value theta equal to 90 degree over here, then the magnitude will be 1 by 4 pi epsilon 0 p by r cube. But why here it is minus I have been written? Here you can see that for theta equal to 90 degree, beta will be 90 degree. That means resultant electric field intensity will be along this direction. This direction is nothing but minus p direction, because p direction is along positive x-axis direction, minus p means along this direction, or we can say that negative x-axis direction. Okay. So here for the equatorial, for the equatorial point, or the point will be situated on the equatorial line, then the answer will be this much. This answer also we have been found earlier whenever we had discussed separately for axial line and equatorial line, right? Okay, so this is all about your electric field intensity at any arbitrary point due to electric dipole moment which is placed along x-axis. Okay, in our next class we are going to discuss behavior of electric dipole in an electric field. Content is already ready. In our next class we are going to discuss with animation. So if you feel that this video or today's video is help you somewhat, please be like and subscribe. Thank you so much for watching this video. Thank you.